I am Neeta Sharma from PM Expert. Today, I will explain logistic regression in machine learning with a simple, intuitive example. We will see what logistic regression does, how the sigmoid function works, and how to make a prediction step by step. First, a quick contrast. Regression predicts a number, like predicting a house price. Classification predicts a category, like pass or fail. Logistic regression is used for classification, even though it has the word regression in the name. Now, our example. Suppose X is hours studied for an exam, and we want to predict pass or fail. We will plot hours studied on the horizontal axis and the probability of passing on the vertical axis. We will place red points near 0 for fails and green points near 1 for passes. Then we will fit a sigmoid curve that turns low probabilities into high probabilities as hours increase. We will also draw a threshold at probability 0.5 and see where the curve crosses that level. The logistic model turns a line into a probability using the sigmoid function. We write P of X equals 1 over 1 plus e to the power of negative, open parenthesis, b naught plus b1 times x, close parenthesis. Here P of X is the probability of passing when study time is X hours. We often pick a threshold of 0.5 to decide pass or fail. If P is greater than or equal to 0.5, we predict pass. Otherwise, fail. Let us use simple numbers so we can compute quickly. Take b naught equals -6 and b1 equals 1. Then the crossing point where p is 0.5 is x equals 6. Now compute two predictions. At 4 hours, z equals -6 plus 1 times 4, which is -2. So p equals 1 over 1 plus e to the -2, which is about 0.119. That is less than 0.5, so we predict fail. At 8 hours, z equals -6 plus 1 times 8, which is +2. So p equals 1 over 1 plus e to the -2, which is about 0.881. That is greater than 0.5, so we predict pass. Why a sigmoid? Because probabilities must stay between 0 and 1. Small increases in x near the boundary change peak quickly, while far from the boundary the probabilities saturate near 0 or 1. This matches many real-world problems like pass or fail, buy or not buy, click or not click. To summarize, logistic regression maps inputs through a line, then through a sigmoid to give a probability. With a threshold like 0.5, we convert that probability into a decision. I am Neeta Sharma from PM Expert. Thank you for learning with me.